Hello and welcome. In this lecture, we are going to be disabling the action that the player was doing when they walked into the cinematics trigger volume, and also removing control. So no matter how much I'm clicking around the world here, we are not able to move the player an inch. But when the cinematic is finished, we are back in control and we can go and try and attack these guards and beat them up and play the game, play our moment. Let's dive in and see how it's done. So we're able to get the right log messages, but this isn't disabling control. We do actually want to do that. But before we dive into disabling control, I want to show you a little problem. That even if I wasn't controlling, so let me just not select the follow camera, if I just click on this guard, I'm now not clicking anything, okay? And watch what happens. I'm not giving it any control input, so it wouldn't matter if we disabled control, but I went up to the guard and killed him because that was the last action I had given. So what we actually want to do is we've got our action scheduler, it's got a cancel current action. We want to call cancel current action when we enter this trigger volume. Whatever we were trying to do before, whether we were trying to attack a guard and kill it, that should now stop because we've entered this trigger volume. So how do we do that? Well, first of all, we want to get hold of our player itself, the player game object. So to do that, we're going to use game object dot find with tag, and we're looking for the player tag. Okay, I'm going to store that into a game object called player, and then on the new line we can get hold of the player's get component of type action scheduler. For that I'm going to have to include using rpg.core and look for the action scheduler and do a cancel current action. Now what would happen if we go and play now, in fact let's give it a go so you believe me, is if I click play and I click on the guard, we are still going to run up to the guard, but notice we're not trying to attack him, we're just running to that location. So to some extent the cancel worked. It worked in the sense that it cancelled the fact that we were trying to attack the guard. But what it didn't do is cancel the movement that we had started. So if you have a look at the fighter, the way we do this is that if we're not in range, we tell the mover to move to this target position, but at no point do we stop that. Well, we stop that once we get in range, but if we don't get in range, when do we stop it? We don't. If we cancel the attack halfway, we never stop it, we just remove the target. So the way to do this would be to, when we cancel a fighter, we also cancel anything that was going on in the mover, so that kind of thing can't happen. This was basically a bug that we didn't have, or didn't have exhibited, because the only thing that could cancel the fighter was the mover, and the mover would then subsequently go on to tell it to move to somewhere else. But here, where we've got nothing else for it to do, we need to be able to cancel. There you go. You saw it happen. He actually stopped in his place when he entered the trigger volume. He stopped moving instantly. So that's what we want. And let's just check it one more time with if we were just moving to another location. So if I'm just moving to this place past the trees, I stop. I go into the transition of the cinematic. So that's working, except that now I do still have the problem that if I walk into there, it stops, but if I click somewhere, I'm still in control. So we want to be able to disable control, and I think with the structure we've got in place here, you should be able to find that pretty easily done. So, oh no you don't, we don't want them to go off and start playing while we're doing a cinematic. Stop the player from being able to control. I think the best way to do this is to disable the component, the player controller component. Now, see if you can find, maybe a little bit of Googling is required to do this, but see if you can find how you can disable a component. It's a generic thing, not something that you have to do specifically or change anything in the player controller code. That's the nice thing about this. So stop the player from controlling, and then re-enable control at the end of the cinematic. Pause the video and have a go. Okay, welcome back. So let's see if you figured this one out. So first things first, we're going to have to use the player game object to get component, and we're getting the component of type player controller. Now this one's not here, so we're going to have to include a namespace for control, And then we are going to call .enable, which is a property on any component, and we can just set that to false. Hopefully you found that in your Googling, your research, or you just remembered. Okay, and then we want to re-enable in our enable control method. So set enable control to true in here. Now the player isn't accessible. I'm actually going to move this up to the class level, so I'm going to cut and paste the game object find into start, and I'm going to make game object player. Can I make that? Is there a handy helpful hint that allows me to bring this up to the level? No, there isn't. So I have to copy this. I'm going to make it a private variable of the cinematic control remover. It's just going to cache the player, and I'm going to update that in start to be the player, and then we can use it in both of these methods. So hopefully that should do the trick. Let's see. So I'm going to walk over the bridge. That stops. And then I'm going to click somewhere in the world, and hopefully that's having no effect. Yes, indeed. I go to the scene. I can see my player is no longer being moved by that. So, however, I can then get control again when the cinematic has finished. So that's all working hunky-dory, exactly how we would like it to work. We've enabled disabling of player control. Now that was the last piece of the puzzle to getting our cinematic moment set up, and I think you'll agree that it now feels quite nice, and you can obviously go ahead and make it feel even more polished than this, spend more time on it, add your own bits and pieces. In fact, I would very much like to see what your cinematic moment ends up looking like, and how the moment as a whole plays all of this bit where you are then having to go through the level and beat up the guards. Do record a video of this and post it against the forum topic for this lecture. I look forward to seeing them. Hello and welcome. It's a new section, and following on from the last section where we were doing our first moment, now we're going to learn how we can string those moments together in separate levels. So we're going to be having a section all about scene management and loading scenes. Let's dive in and see what the prototype has to offer us. So here, this prototype is looking different from the scene that you've just created because it was based off the previous section. But if I run in this direction, fade out, fade in, and we're now in a different scene. We're going to be learning to do this and creating portals in the levels. So here I'm in a transitionary level. If I go to the portal at the end of it, which is just a basic corridor, then I fade out and fade in, and I come back actually to the top of the previous level. So if I zoom out, what we've got is a situation where there's a portal here at the end and a portal here at the beginning. That's where I just came in. So we're going to add multiple portals that take you to different parts of different levels, and that's going to allow me to teach you about coroutines that run between levels, asynchronous scene loading to allow us to say, hey, wait for the scene to load, then fade back in, and how to do those fades in the first place. All this scene management stuff, quite cool. Let's dive in and get started with implementing scene management in this section.
Hello again, welcome. In this video we're just making ourselves a really simple second sandbox scene, say that quickly, so that we have a place to load into and save from so that we can start working on our scene management functionality. It's a little bit hard to do scene management with just one scene, so we're going to make ourselves a second one. Let's jump in and get started. Okay, you're probably going to hear me use the words scene and level a little bit interchangeably when it comes to what we're doing here, because technically this is a level. You enter it, you go through, you exit. It's also a moment because we've made this as a moment based upon all the things we've talked about, and Unity names each of these things as a scene. This is a scene file, so we could also call it a scene. So, you know, I'll probably be calling it as a level. That's just what I have in my brain. And what I'm going to do is create a mechanism where, see this entry point and that exit point, or that entry exit point over there, I'm going to pretend there's another level just in here. So it's just going to be a small little thing where the player can run from one end to the other. And then as Sam is hooking up the save and load functionality, we'll have a little portal here. and then we'll also have a little portal down there, just so we can make a little bit of a loop the whole way through, which I think will be a little bit nice. And the first thing I'm going to do is just delete my quad over here, my quad that I've been using as prototyping. Thank you for that, we don't need it anymore. Now we have our sky back again. And what I will do super quickly is, before I jump into the next scene, is I'm going to grab a copy, or I'm going to duplicate the fence that I've got here, move the fence over to this kind of entry-exit point, just so I can get a little bit of language to the player, or to ourselves as well, that when we see these fences, that means we're entering a different area or about to load into something, just to see if that makes sense, see if that's a good system. Just quickly play, make sure that looks okay. Run, 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 run. Okay, and then broom, that's around, when that tree gets in the way, that's around where we would want to load, which I think is cool. Okay, so we've done that little bit of tidying. Let's save that up. Now, what we need to do before we go and jump into our next scene is to make sure we've got the right things prefabbed. So our player is prefabbed. Make sure I haven't forgotten to do any overrides. Yep, that's looking good. We have our one directional light. That's probably going to be the same. Our camera. We haven't prefabbed our camera. When I say we, I should say me, because I haven't prefabbed the camera. So I'm going to find my game and then core. In here we've got the follow camera. That's the old follow camera, which I'm going to delete. Yes, you can delete that. So I'll grab our current camera, drop that in, grab our follow camera, drop that in. We'll see if there's anything we need. We've got our enemies prefabbed, yes, and cinematics. We don't need to take our cinematics over. So I think this is looking pretty good. It's mostly just player and camera that we need to get in there. So I'm going to save this up. And now we want to go to File, New Scene. You've probably done this a million times when you've been making games. Now, we will start by saving our scene. Save as. Where do we want to save it? Well, into Scenes. I can call this Sandbox 2. Not the best name. In the future, we'll do a little bit better with our naming. But for now, fast and loose with our sandboxing, so it's perfectly fine. I'm going to right-click, create a 3D object, terrain, drop that in, make it way smaller than it wants to be at the moment. Make this 100 by 100, just guessing that's an okay size. Make sure we go on to lighting, and where are we here? Auto generate, turn that off so it's not sitting there trying to do the lighting over and over. So my 00 looks like it's right in the middle. If I drop in a player, so we'll go to our core characters, there you are. Drop the player into the hierarchy, and then right click, reset transform. It's way up in that corner over there, so that looks to be our 00 corner, which means I'm going to grab my terrain, move it to -50 and -50 on the X and on the Z, because I like to have my terrain, my world right in the middle. If I've got something centered in my 00, so I just reset the player back to 00, I like to have it centered in the middle. Now let's just quickly sketch out where we're going to do our level like before. There's parts of this video I'll speed up if I think you don't need to see them, and other bits where I'll talk you through it. So we need to bring in our terrain textures. So over on terrain, click the paintbrush, paint texture, edit terrain layers, add layer. Now because we've got these already, we shouldn't have to go and create them from scratch. So double click on dirt, edit, add layer, green grass, edit, add layer, light dirt, edit, add layer, light green grass. So you can see that they weren't automatically part of our scene because the terrain layers are scene specific. Each scene you're going to have to go and set up your layers all over again, but if you've already made them, created them, and tweaked them, then it's as easy as just going add layer as I did just there. And the challenge I've got for you is to make a second sandbox level, be clear on where the player can enter and exit your scene, and it's up to you how much polish you want to put into it. I'll be making mine really quick and dirty. I'm not going to put a lot of time and effort into it. I'm going to make it so it's quite small so that when we're testing out our entrance and exit, we don't have to run a whole way through our level to do that. So I'm going to create my scene now. I'm going to speed up the video so you can see all the action. You can create yours at the same time or watch me make mine and then make yours as well. Like I say, if you want, you can just have a flat ground plane and that's it. You can be done. You don't have to put a lot of effort into it. But if you do, here's a good chance to flex your level creation muscles again. Okay, I'll start off by just painting on the ground where I think my level should go to. You can see those two dots pretty close because I just want it to be a close little sandbox level. Just trying a few different brushes here to see what look I think looks good for my sort of mountains around the outside. Just sort of splash them around, leaving not much space in the middle. Like I say, this is really sandboxy. just so I've got a short path to go from A to B, painting some stuff brown. You can see I've accidentally gone and made myself another terrain here. I'll delete that later on. Not sure how that happened. I didn't see that as I was creating it, to be honest. Okay, putting in some trees. Going for the different the other sort of tree that I've got in the asset pack here. Some of the trees are going to get in the way of the camera later on, so I might need to tidy those up. But just slapping them down, putting the path along the pathway, finding my fence so I can have my language to the player. This is where we enter. This is where we exit, just the same as I did at the end of my other level. And then what are we doing here? Duplicating, putting the fences down the other end. Rename my terrain to Sandbox 2 Terrain. So let's put in the cameras and see if this actually works properly. So where are we looking for that? Under Core, we'll drop in our camera and drop in our follow camera. On the follow camera, we need to change the follow to be the player. Okay, make sure navigation, bake, we bake our nav mesh so that we do have one. Okay, now let's click on play, see what happens here. Okay, run, 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 run. It's kind of cool sideways. That's not the way I'd intended it, but not too bad. So I'm just going to tidy up my trees, the close side to the camera. Now make sure this is all okay, that our character can move around, yep, through the gates. And I'll just put a little bit more of an obvious barrier down the end here that you've reached the end. Okay, that's looking pretty good. One last final play to make sure everything's in order as we're expecting. Looks my light is still baking, or maybe I need to change up the sort of light I have in there. I get rid of that one last tree, but then run, 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 yeah, and then we have our other load area. So, super simple, there's not much going on with this level. And the last thing I need to do is throw in a skybox. So, where did I bring in my skybox? Asset packs. It was Boxphobic, I believe. Skybox. Under Materials, Skybox, drop the skybox in. So, we got the same skybox. There we go. Probably a little bit silly me having all these trees in the level, so I'm going to go and get rid of all these ones up the back here that we're never going to see. Okay, that's looking a little bit nicer. I'm going to save up my level. And while my video was paused, my lights have finished baking. And then let's finish up with a little bit of tidy up. I'm going to create myself an empty. I will rename this to be Core, as we did in the previous scene. Reset the transform on that. Grab the player, the camera, the follow camera, drag those into Core. I've made a bit of a mess here. I've got two terrains. Let's see. That terrain looks like that one there. And the one that I renamed Sandbox 2 Terrain, sorry, that was actually some sort of misclick. So I'm going to delete that. Then the terrain I've got in my scene, I will call this Sandbox 2 Terrain. Okay, clicking on assets, I can see I've got these two terrains here. One is new terrain. That looks kind of like what I've slapped down in there. And terrain data doesn't look like we need that one there. So I'm going to delete that. And this new terrain, I'm going to rename Sandbox 2 Terrain. So this terrain now should match this terrain in our scene, and I'm going to drag this terrain into my scene. A little bit messy, I know, but I think we got there in the end. I've got this one terrain. Let me just reduce my folder size here so it's a little bit more seeable. This sandbox I'm going to drag into Sandbox 2, so that should belong in the right place. The scenes we've got at this higher level so I can see them easily. Great. Sandbox 2 terrain I'm going to drag into my environment. Game object, excellent. Directional light into my core. Main camera we don't need because we've got ourselves our follow camera. Everything in there should now be complete. Save that up. Zoom back in a little bit. Click on play. Just a final check to make sure it works. Yes, it does. Awesome. Okay, that's pretty good. That's it for me for now. Back over to Sam so you guys can start implementing your scene management functionality.
Hello and welcome. In this lecture we are going to set up some triggers that allow us to switch scenes. So when I walk into this switching area, this portal area, I end up being taken to Rick's new lovely corridor scene. So hopefully this is going to be a little bit of revision for you folks on how we load scenes in Unity. Let's dive right on in. So as Rick mentioned in the last lecture, we want to create a portal between these sets of gates. How are we going to do that? Well, the key is going to be triggering some code. So we're going to want a trigger very much in the same kind of setup as a cinematic. So I'm just going to rush through this quickly. We're going to go ahead and add an empty. I'm going to rename it to portal. And on here, I am going to add some components. I'm going to add a rigid body because we need that to deal with getting our events to make sure the trigger gets events. So we're going to use switch off gravity, add is kinematic so that it doesn't try and move around with physics. And notice that we're adding the rigid body to the triggers here. You could add the rigid body to the player instead, and that might be something to think about doing in future. For now, we're not going to. I'm going to add a box collider here as well. Now, notice this is not showing up because it's in some random location. A great way to sort that out is to make a prefab of our portal. Now, where is a good place for this? I think it's quite core to have a portal, so I'm going to put our portal prefab into the game core folder. And then I'm going to remove it from our scene and bring it back into the scene by dragging on to the scene view so that it is positioned in a good place. Now I'm just going to rotate it and modify the size so that we can't help but go through this portal when we walk between these gates, which is the idea after all. So there we go, that's nice and big and should do the trick. I'm going to save the scene, and we're going to leave those size parameters not applied to the prefab, but other stuff we're going to want to apply directly to the prefab. So I'm going to open up the prefab so that we don't forget to apply it, basically, because that's always a problem. Oh yes, one more thing we're going to want is to add the layer to be ignore raycasting on our portal prefab. And then we're going to want to add a script for us to call. So I'm going to create a new folder here called Scene Management. And in that, I'm going to create a new mono behavior called Portal CS. And I'm just going to skip over the bit where I write out the boilerplate code, which you know how to do by now. Mono behavior called Portal in the Scene Management namespace, reflecting exactly how we've set up our scripts. Now, in here, I want to do an on trigger. On trigger enter in particular is that's where we're going to trigger off loading up the next scene. So here I'm just going to put in a print statement which should tell us whether our portal has been triggered or not, and I'm going to not forget to add this portal component to our portal prefab. Go back up to the scene, let's hit play, see what's going on. Can we trigger off this portal? If I walk into it, it is not showing me that it has triggered. So why is that? Let's have a look at the portal, check a few things. Aha, the box collider is not, in fact, a trigger. So let's go into the prefab and make it so. It is now a trigger. And let's try it one more time. I am noticing some other errors. We'll get to these in a second. Okay, it did get a portal triggered notification. So that seems to be working as we would like. Getting a portal trigger each time we step inside that portal. Cool. So the next bit's going to be a challenge to you, but before we do that, there is this reference script unknown on this behavior. So what's that? If I go to the intro sequence, you may have worked this one out for yourself, but when I deleted whatever the fake, I think it was the fake playable director, I forgot to remove it from this game object, so it's got a broken reference. We're just going to go ahead and remove this component. There we go. And that should make that error go away. Let's just try it one more time. Yep, no such problems this time. Now, notice that we are also getting triggers when it's not the player going in. We know how to deal with that. So, time for your challenge to load the correct scene. So, fill in on trigger enter, and the player should be the only thing that sets it off. Otherwise, we're going to be switching scenes all the time, and that would be absolutely no good. Try and keep your dependencies to a minimum, so don't try and include basically try and include no namespaces if you can get away with it. And if you're thinking, cool, I know how to do that, then go off and do that, and maybe you can do a little bit of YouTube, a little bit of Google research, YouTube research, whatever, to see how to load scenes if you've gone a bit rusty on that. If you don't and aren't quite sure, wait for the tip, and the tip is that you want to be using scenemanager.loadScene. Pause the video and have a go at the challenge. Okay, welcome back. So, as we said, we want to check that we're the player, so let's put an if statement in here. I'm going to just check that the object we're colliding with, .tag, is in fact equal to player. And if that's the case, then we can proceed to try and change the scene. So that's going to be scene manage, what was it? Scene manager dot load scene. Now you might have to include a namespace for this. It's going to be unityengine.scenemanagement, and that will now work. And then we've got a few overloads for load scene that we could choose from. So we could get the one that does it based on the scene name as a string, We could do it, that's another string one, more string ones, but there's ones that have the build index. Now, I'm kind of a mind to go for the build index ones because if we then rename a scene, we're not going to have issues with having to rename it everywhere. Okay, so I'm going to add a serialized field that allows us to configure the portal as to which scene it's going to load. So it's going to be an int, and it is going to be scene to load, like so, and by default we will start with a -1, which should throw us some errors if we haven't decided what to do with it, or if we haven't actually configured our portal. So that should be basically almost there. We need to set up the scene indexes. So to do that, we need to go to, I always forget where this is. So it is File, Build Settings, and then we can drag in the scenes from the project view. So if I go to my scenes folder and grab first our sandbox scene, then sandbox 2, so you'll see that sandbox 1 has got the index 0, sandbox 2 has got index 1. That's what we want to know, because now when we have our portal selected, we've got this scene to load, and we want to make it scene 1, so that we load Rick's lovely scene. So I'm going to go ahead and save that and see if, when running into it, we're going to trigger it to load a scene. Bam! We have. So to recap, we have created a portal game object, we're handling the trigger event and loading a scene off the back of it using a build index. In the next lecture, we're going to work out how to make things a little bit more sophisticated than this. But first, we're going to need to know a little bit more about coroutines, or do a recap at least, so I'll see you there. Hey folks, and welcome to another video with my face in. This is because I am going to take you over a recap of what it is that we're doing with coroutines. You've probably used coroutines before. You may have used them as a bit of kind of magical syntax, and I want to take you over why that magical syntax works. Okay, let's dive in and have a look at lists and arrays and enumerators. Okay, why do I want to start with this? Because these are the building blocks of coroutines. Now, just put coroutines to the side for a minute now, because you're not going to understand why I'm talking about these until I bring it back round. So let's just talk about enumerators. What are they? Why do they exist? So you've seen enumerators probably in the context of coroutines before, but we're going to be using them differently. The way we're going to be using them is more like lists and arrays. Now, if lists and arrays were Pringles, then lists and arrays would be Pringles in a bowl, where you can pick any Pringle that you want from the bowl of Pringles. On the other hand, the Pringles in a tube are like an enumerator. You can only take the topmost Pringle at any given time. Now, this might seem like a loony idea, and you might be going, why is Sam rambling on about Pringles? Well, Rick thought it was a good idea, so blame it on him. He thought it was a good analogy. So the idea is how you can access these. Lists and arrays you can access any way you like. enumerator is an interface, and it is restricted to the ways you can access it. So in fact, it is an interface, as I said, and we've used interfaces before, and the enumerator interface basically looks like this. It allows you to get the current object. So this is a getter, by the way. This is how it's written inside an interface. It's basically just like a property. So you do .current, and it gets you the current item in the enumerator, basically the topmost Pringle. And then you can call move to next, which basically takes the Pringle out of the packet and consumes it, and you go nom nom nom, very tasty, and then the current will be the next Pringle on the top of the pile. And this, you'll notice, returns a Boolean. Why does it return a Boolean? Because if there are no more Pringles in the tube when you remove one, then it's going to return false, basically. It's going to say, I can't take any more Pringles out of this tube. It's empty. You need to buy another Pringle tube. So how do we use enumerators when not talking about Pringles? So this is my hungry child function, carrying on with the analogy that we had previously. We're going to have an enumerator that returns types of Pringle. So it returns a Pringle class, Pringle class. So we've got this Pringle tube. We're calling the get Pringles method to do that. I'm going to talk about what that is in a second. And what we can do is we can do a while loop over the Pringle tube. So this is a bit like doing, it's the for each Pringle in enemies, for each Pringle in Pringle Tube is what I mean to say there. And while we have more Pringles in the tube, we move next. We try and take a Pringle out of the tube, and then we can get the current Pringle, which is the one at the top, and we can eat that Pringle. So that's how enumerators work, basically allowing us to pop items off that Pringle tube, as it were. Now, how do we build the Pringles? Because we've got this get Pringles function. How do we return an enumerator? Well, this is one straightforward way, is that we can take just a list, create a list of Pringles first and foremost. We can iterate, create a for loop. In this case, I'm doing a for loop of 1000. And I can create a new Pringle. I can stamp a serial number on the Pringle. This will be important later on. And I can add the Pringle to the Pringle tube list. And then at the end of my function, I can turn a list into an enumerator, because if you think about it, a list is more powerful than an enumerator and can definitely implement the enumerator interface. So you can just convert it into an enumerator, and then it just gets accessed one by one. So this is all well and good. That's if you want to build your entire set of Pringles before you start. But one of the really cool things about enumerator is that it allows you to lazily build Pringles. So we're going to talk about yield return and how it can make us allow us to create essentially an infinite Pringle tube. So the get Pringles method, let's start in the same way. It still returns an enumerator which contains Pringles, basically. And how do we do this? Well, still got that for loop of creating 1000 Pringles, but instead we create the new Pringle, we stamp the serial number as before, but we yield return the Pringle. That's the one item. And what's going on here is that when we yield return, we are then waiting for the code that called us to call move next, and then it will carry on executing this loop, but it only executes up to the first yield return until move next is called. It's pretty cool. It's actually pausing this function midway as we are executing it, basically. So it's a quite cool piece of C# language feature. So what I've done here is I've unrolled the loop, so you can see that we've got the get Pringles, then we're doing a move next, get current Pringle, eat, move next, get current Pringle, eat. And so this would go on and on, but for now we just unrolled it 3 times, and similarly we've unrolled the loop 3 times here. So let's just have a look at what the execution flow would be doing. So first of all, we execute to the move next, and nothing has happened inside get Pringles. Then we call move next, so it goes to get Pringles. Notice it didn't do it when we called get Pringles initially. It's doing it now when we called move next. It executes down to the first yield return and then returns execution flow back to the hungry child function, where we proceed to get the current Pringle and eat it and go to the next move next, which then goes, and notice it doesn't start from the top of the function, but starts from where we left off, from this yield return. It goes and carries on executing, and it's remembered all of the variables, what stage all the variables were at, which is pretty neat little trick, and go back and so on and so forth. Now, what could happen at any point is that the hungry child could get bored and run off, and the enumerator, or the get Pringles method, would remember where we left off, which is pretty cool. And if the child came back and continued consuming at a later date, then we would be none the wiser in this method. We would just have waited longer, but we would have carried on remembering all the state that we were in. So that's pretty cool. And you'll notice that that's somewhat like some types of method that we want to write. We want to be able to pause and wait for 2 seconds, for example. So that is what Unity have realized, is that you can use this enumerator setup with yield returns to create yourself very cool functionality with coroutines. So let's have a recap of what the functionality of coroutines actually is. So you need to call start coroutine on a method that has a return type of enumerator. And now you can see that this enumerator is really just a Pringle tube full of these kinds of instructions, telling it to wait for seconds, wait for fixed update, and wait for seconds. So what's going on Unity's end? Why has it got it set up like this? Well, this is a kind of simplified version of how coroutines might work on the engine side. So Unity would keep a list of IEnumerators, the coroutines, and we'll call this the coroutine directory. And start coroutine would look something like this. Basically, we add it to the directory. That's all. That is all the start coroutine does. It adds it to the directory. But every update, Unity is going to check through all of the running coroutines, all the coroutines in that directory. And it's going to say, is it ready? Has it executed enough? So it's going to look at the current top value. So that's going to be something like a wait for seconds instruction, and say, have I waited already 2 seconds since this instruction was returned to me? If so, if we have waited enough, then we can call move next on the coroutine, and the side effect of that is that it's going to execute the code after the yield return. So it's going to execute the code after the wait for seconds. So it does exactly what we want it to do, waits for seconds and then moves on. So that's basically the idea. It kind of goes and calls move next when we have waited enough. And obviously Unity has more complexity than this because you can wait for all sorts of things like fixed update and so on and so forth, but this is the crux of how they are working. So I would like to challenge you to have a little think about why we use IEnumerators. Think of at least multiple use cases, a couple, of one of which is going to be the coroutines, of course. Explain the coroutine use case, but think of some others as well. What other use cases can you think of for IEnumerators? And what makes IEnumerators good for this particular use case that you're thinking up? This is the end of the video now, and I would like you to go to the share link and share your answers to this IEnumerator challenge. And I look forward to seeing you in the next lecture where we'll actually be using these coroutines to run code between levels. I will see you there. Hello and welcome. In this lecture, we aren't going to be doing something massively impressive, but we are going to lay the foundations for being able to transfer information between scenes. So if I walk through this gateway here, you'll see that there is a scene loaded message being printed. And interestingly enough, that scene loaded is being printed from the portal, which was a game object in the previous level, not from this game object, none of the game objects in this level, but one from the previous level. So that's what we're going to be able to do, get notifications of when we've finished loading a level and keeping our game objects alive across that level load. Let's dive in and find out how. So at the moment we've got a way of going from scene 1 to scene 2, however we don't have a way of going back. If I play at the moment in our sandbox 2, the corridor level, then I can try and go back this way, the way I came in, and nothing happens. The reason for this is at the moment we do not have any kind of portal, so let's go and find where our character's at. Here he is, and I am going to put a portal in here. So I'm going to go to Game Core, find my portal, and drop the portal into the level, and then rescale the collider so that it will catch everything. And there we go. So let's try this out. So I need to hook up this portal, needs to load scene 0. Let's go ahead and play and walk through it. Sure enough, it takes me to scene 0, but not to the place where we went through, right? We want it to come out here, where the gates are. If I go through the gates, I want it to take me back to where I started, which currently it isn't doing. And of course not, because we're just loading the scene and our character is ending up where it ends up. What we want to do is remember which portal we came from so that we can then say which portal we should move our character to. Now, to do that, we need to know when the scene has finished loading and transfer some information into the new scene. Now, a really neat way of doing this is actually with coroutines and asynchronous scene loading. So what we can do is all in one method we can load a scene. So I'm going to do this by creating a new coroutine method here, a private returning IEnumerator, which I'm going to have to include the right namespace for, and I'm going to call this scene, or just transitioning to the new scene basically. And this is where we are going to put this scene load right in here. And I've got to include the right namespace, which is using system.collections. And we've got this transition which is complaining not all code paths return a value. So that's because we aren't doing any yield returns inside our enumerator. So for now, I'm just going to put at the end of it a yield return null to get rid of that error. And what we want to do is when we enter the trigger, we want to call start coroutine with our transition coroutine. So remember, as of the last lecture, you know that what this is doing is it's putting that coroutine in a directory, and it will be running the code up until the yield return, and then it will pause and let Unity decide when to carry on running this coroutine. So what we want to do is figure out when the scene's finished loading, and to do this we can actually just use a different function on Scene Manager. So if I have a look at what's available to us, if I start using the autocomplete, I can look for load scene async operation, and in here you can see that the return value is a return value of async operation. We can give it the same basic, like the build indexes and load scene mode as we've done before, and I think that is basically what we're going to do. We're just going to pass in the load index, but we want to find out when this is finished, and it returns this async operation, which actually, if we just yield return that, it's going to do what we want. Basically, it's going to say, hey Unity, run up until this point, and we load async the level. Then it's going to return the async operation to Unity, and Unity is going to go, okay, I know what to do that. I know what to do with that. I need to call this coroutine again when the scene has finished loading. So that's what we're going to end up with. And what I want to do is, just for this lecture, I want to get to the point where we are printing out scene loaded, like so. So that's the idea, but there is something that is going to stop this from happening, and that's the fact that as soon as we load this new scene, our portal game object, the one which has the coroutine, gets destroyed, and so does the coroutine itself. So this is the challenge to you, to not destroy this portal on loading the new level. Hopefully you already know how to do this. You can Google around a little bit if you don't, so keep the portal around. Make sure that the print happens when you load the next level. I should expect to see that scene print happening in the console log, and then make sure the portal is actually destroyed after the print has happened. So pause the video and have a go. Okay, so hopefully you can run this yourself and see that you're happy that this print statement's not working. But if we do a don't destroy on load, and we call it with our target to be the game object, so we don't destroy the portal game object at all at this point, then we can go ahead and yield return this, and our coroutine will still be around to print the scene loaded afterwards. And then, just to be a good citizen, I'm going to destroy my portal and not leave it hanging around afterwards, because, well, it could be confusing. For one thing, your character could walk into it again, and that would be really weird. So we're going to go ahead and get rid of the object as soon as we've printed out. Now, don't destroy and load only works when your game object is at the root of the scene, so it can't be under any other game objects. Now, we will find a way of getting around this in later lectures, but for now, just make sure that your portal is at the root of the scene. So let's give this a go. I would expect that if we walk through this portal, we are going to get a log message on the other side. So walk in, have a look at the console, and sure enough, the scene loaded was printed, and it's not by a mono behavior that's anymore in the hierarchy. So to recap, what we've got here is a coroutine that runs between scenes. Here is before the scene load, here is after the scene load, and that allows us to transfer, or lays the foundation for us to transfer information into the new scene from our current portal, which we'll use to reposition the player. Good stuff. See you in the next lecture.